All right, welcome to section 3.3, proving lines are parallel. I got some seriously messed up hair right now, and so that's got to be distracting to you, and I'm sorry about that. Section 3.3 with parallel lines, proving parallel lines, is a lot like section 3.2. In fact, 3.3 is basically the converse of section 3.2. So these words are all going to sound familiar. Okay, so if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. Let's look at an example over here. If we have these lines over here and we know that this angle is 75 and this angle is 75, if that's 75 and this is 75, those are congruent angles, they are corresponding angles, and if corresponding angles are congruent, then these lines are parallel. The reason that we'll say for this is the converse, the opposite of what we had on the other side. The corresponding angles congruent, then we have parallel lines. The other way around, in the previous chapter we said if we have parallel lines, then those corresponding angles congruent. It's the same idea, we're just going the other direction. We're saying which lines are parallel because of the angles being congruent instead of the angles congruent because the lines are parallel. So if this angle up here is 105 and the corresponding angle of that is 106, because those are not congruent corresponding angles, they are corresponding angles but they're not congruent, then those are not parallel lines. The same idea happens here if two lines are cut by a transversal and the alternate interior angles are congruent. Then the lines are parallel. So if that's 125 degrees and its alternate interior angle over here is also equal to 125 degrees, then those lines are parallel. You can make that conclusion. So the reason we'll say if alternate interior angles are congruent, then we have parallel lines. And like we did up above, if these alternate interior angles in this example, one is 62 and the other is 63, if they are not congruent, then the lines are not parallel. Okay? You probably know what's about to happen here. If two lines are cut by a transversal and same side interior angles are congruent, like this. If we have those 45 degrees, those angles there are 45 and 45. Oh, wait, doesn't sound right. Same side interior angles aren't supposed to be congruent. They're supposed to be supplementary. So 45 plus 135. If those angles add up to 180, these same side interior angles add up to 180 degrees. If they are supplementary, then we have parallel lines. Same side interior angles are supplementary, then we have parallel lines. And then we have the fourth rule in section 3.2. We have the converse of it as well. In a plane, two lines that are perpendicular to the same lines, they have to be parallel. So what this is saying here is if you have these two, if you have a line that is perpendicular to two lines, then those two lines have to be parallel. That is what that's saying. Think about it. That's like having alternate interior angles congruent because they're all equal 90. It's like having same side interior angles are supplementary because they're 90 plus 90 is 180. It's like having corresponding angles that are congruent. All of the angles in this diagram right here are equal to 90 degrees. Okay, so what's this going to look like? Well, the first type of question you'll be seeing and doing is to state which of the lines are parallel based on what's given. So in order to do this, we need to basically figure out, do we have corresponding angles that are congruent, alternate interior angles that are congruent, or same side interior angles that are supplementary? Well, let's look over here. We have 85 degrees and 100. Definitely, those are corresponding angles. They're definitely not congruent. I see 34 and 19. So nothing stands out as congruent right here, but let's see what's missing. This angle measure here and here are missing. If we subtract 85 and 130 from 180 and then do the same thing from 119, these straight angles leave 61 degrees. Well, look at there. Those two angles are congruent. Those are corresponding angles that are congruent. So if we have corresponding angles that are congruent, then there have to be parallel lines. Which lines are they? Well, it's not going to be the transversal. It's not PQ. It's going to be PS and QR that are the parallel lines. So we can now conclude that QU is parallel to PS because the corresponding angles are congruent. PQ is the transversal. Look at number 2 down here with me first of all. what types of angles are 70 and 112? Those are same side interior angles, as are 70 and 110. Those are same side interior angles. Okay? So what must happen for same side interior angles to produce parallel lines? They'd have to add up to 180. Which one adds up to 180? Well, 70 and 110. So that pair of angles has AB as the transversal, AD and BC are the other lines. So AD is parallel to BC. The reason, same side interior angles are supplementary. See what you can figure out here and now and pause the video. Try 1, 3, 4, 5, and 6, and we'll talk about them in just a second. Okay, how'd you do in 1 and 3 right here? Did you get these answers? See the alternate interior angles that are congruent? Look at number 4. The congruent angles there are 46 and 46. Those are what type of angles? Same side interior angles. Are same side interior angles are congruent? Well, they can be, but that means we don't have parallel lines. Number 5, did you see 53 and 53 are congruent? Those are corresponding angles that are congruent. Number 6 had a lot of stuff going on, really. It's a little bit tricky. Did you see the alternate interior angles that tell you 35 degrees and 35 degrees, and then also 40 degrees and 40 degrees? Those alternate interior angles make those congruent. But then also, because ED is basically parallel to two other angles, or two other lines rather, then those other lines have to be parallel. It's basically, there's another theorem that I didn't put on this sheet that this demonstrates. If one line is parallel to two other lines, then those other lines are parallel to each other. It's a form of substitution. We'll talk about it later as well. All right, on the back side we see another type of question that we'll be seeing. It's the same idea, but in this diagram that's over here on the right, if this information is given, if angle 1 is congruent to angle 8, are there lines that are parallel? In this case we got angle 1 and angle 8. Those are what types of angles? Alternate interior angles. So if angles 1 and 8 are congruent, then yes, we have parallel lines. What are they? J is parallel to K. So answer the rest of these. See how you do. We're looking for alternate interior angles congruent, corresponding angles congruent, same side interior angles are supplementary. JK, a lot of them. In fact, will you write "just kidding" at the top of the page for me? Thank you very much. 13 through 17 is the same type of set of questions. We're just looking for those angles that are congruent or supplementary. Hopefully we're doing okay. All right. Example 2, here's the other type of question. These questions will look like the ones we did in the last section where we're solving now for variables. Example A here, find the values of x that make AE parallel with BE, or BF rather. So let's see, we have AE and BF. Find the values for x. Well, what's x in this case? Well, we have, those are corresponding angles for that transversal AC or AB. So those corresponding angles would have to be congruent. So 5x plus 3 has to equal 6x plus 1 in order for AE and BF to be parallel. So what must x be equal to? We go solve for x, we get 12. That's the value for x that makes that congruent. All right, so basically now we've established that AE and BF are parallel. We did that over here. So if those are parallel, what's the value of y that's going to make AC parallel with DF? This whole diagram goes together. So we now know that x is equal to 12. So that means that these same side interior angles here, 5x plus 13 and 8y plus 3, have to be what? Those are same side interior angles, they're supplementary, so they have to add up to 180. Well, we can plug in the 12 for x. So this angle here is really equal to 73 degrees. 5 times 12 plus 13 is 73. So 73 plus 8y plus 3 has to equal 180. These are same side interior angles. They have to add up to 180. Go solve for y, and we get y is equal to 13. So there is our answer. Y is equal to 13. All right, use those examples as kind of your template. You're looking now on 18 through 22. You're looking for alternate interior angles that would have to be congruent to have those parallel lines. Same side interior angles have to be supplementary. Corresponding angles have to be congruent. Give those suckers a shot. If you're having to solve for x and y, you usually have to solve for one variable before you can solve for the other one. All right, hopefully you pause that video as you're working those questions. I don't want you to just write the answer. I do want you to check your work with these answers and see if they're right. Of course, if you have questions, come see me, but what's going on here, those got to be congruent, right? Alternate interiors. These have to be supplementary. They're same side interiors. These have to be supplementary, same side interiors. These have to be congruent, alternate interiors. These have to be supplementary. So once you solve for x, you use it. Same idea. Alternate interiors, corresponding, congruent, congruent. Get some rest. We'll talk about this next time.